This is Honors Algebra 2 Pre-Calculus. We're doing 1.4 in Algebra 2. I'm doing example 6 for our notes, but it's actually example 3 from the textbook on page 32, which I'm going to read to you because I'm not going to write out the entire paragraph. That's a weird waste of our time. So right before the example given on page 32, they talk a little bit about Newton's law of universal gravitation, and that it gives ratios that allow you to compare the weight of objects on Earth to weights on other planets or other celestial bodies, right? So for example, the weight of something on Mars relative to the weight of something on the Earth is a ratio of 38 to 100, right? So, for instance, if I weighed 100 pounds on Earth, which is, by the way, way rounding down, but let's pretend I did. If I weighed 100 pounds on Earth, I'd only weigh 38 pounds on Mars, right? So that's kind of the idea, right? So then we're given this word problem in example 3 of the textbook, but that's our example 6. So I'm going to read that to you, and then we're going to walk through it. So, Sojourner is the name of the first rover, robotic roving vehicle, that was sent to Mars. Sojourner weighs 24.3 pounds on Earth and is about the size of a small child's wagon. In part A, they ask us to find the weight of Sojourner on Mars to the nearest tenth of a pound. Now, I am going to make the point that it bothers me to no end when you're asked to do things to tenths or even hundredths, because an AP test makes you go to thousands, but we're going to go ahead and cave and go with the wishes of the book here. For the record, on any exam I ever give you, on anything I ever give you, I want you to go to thousandths place in every single situation, unless if it's money, which should be round to hundredths, because we don't go to thousands in terms of money, or unless if a problem expressly says to the nearest whole person, or the nearest 100,000 people if it's population. But anyway, here we will do what the book is asking, and we'll go to the nearest tenth. So here's what I know. I know that essentially the weight on Mars relative to the weight on Earth is 38 to 100, right? So I know that in this problem, in part A, I want to find the weight on Mars of the little wagon, right, the Sojourner, and it is 24.3 pounds on Earth, and that is apparently close. It's not exactly right, but we're going to call it 38 over 100. So I can cross multiply, right, because it's a proportion, so I get 100 Wm equals whatever a 38 times a 24.3 is, right? Which it would seem comes out to be about a 920, right? So that's a 920 divided by 100, so I get that this thing is apparently approximately 9.2 pounds on Mars. The second thing I'm asked to do is write the direct variation equation. Well, the funny thing is I was basically given that equation already, right? Because I was given that Wm over We is equal to 38 over 100, right? So if I just multiply the We over, Wm equals 0.38 times We, there's my direct variation equation, right? So you don't really have to do much to it. And again, these are both approximate, right? These are all approximate technically because it's not actually an equal value. They were just giving us an approximation. But that's the idea. So that's your example 6. There are a few word problem type things in the practice problems, but again, sort of fundamentally, you're setting up the exact same situation that we did in the non-word problems. It's just a matter of putting the numbers in the right spot.